A warm welcome to everyone to the course Fabricating a Simple LED Power Circuit. This is the circuit which powers up two LEDs, LED1 and LED2, see as shown in the circuit above circuit diagram. We are going to fabricate this in a PCB. The circuit also has an option for AC input source. By adding a 909 volt step down transformer in the input side of the circuit as shown. See, the diodes D1 and D2 are used for full wave rectification. Actually, the capacitor filter is not shown in the circuit for simplicity of the circuit, as this is the first circuit we are going to discuss. If an AC source is used, then the battery should not be connected. So we can see that a 330 ohm resistor is connected in series with the LEDs in order to limit the current and maintain required voltage at the output. Next, we will move on to the calculation of the resistor value. See the calculation. Normally, a 5 mm LED draws maximum 30 milliamps current and requires 2 volts to power up. Here, sorry. Here we are going to use that is you are going to design for 20 milliamps current and 1.5 volt per LED. Okay, for two LEDs in series, 3 volt is required because voltages in series are additive. So, two LEDs of 1.5 volt each requires 3 volts to power up. As a 9 volt battery is used, the output required is 3 volts. The remaining 6 volt need to be dropped using a resistor. So the resistor value is to be calculated using Ohm's law. See the calculation. So there is 9 volt minus 3 volt. The 3 volt is the output, 9 volt is the battery voltage. So that the difference is 6 volt should be dropped in the resistor. So 6 volt divided by 20 milliamps is the current through the circuit. So it gives you 300 ohms. So the nearest standard value resistance is 330 ohms value. So now we need to think about the power rating of the circuit. So what should be the power rating? Maybe quarter watt resistor, half watt, 1 watt, which resistor we are going to purchase. So see, the power is equal to V into I. So 6 volt is dropped across the resistor and the current is 20 milliamps. So with this we get at 120 milliwatts. So we can use a quarter watt, that is 250 milliwatts of resistance, power rating value. So it means a quarter watt resistor of 330 ohms is chosen as the resistor and should be purchased and used in the circuit. Thank you.
So first of all, we should know what is a PCB. It's a printed circuit board. A PCB is a media for mechanical support and electrically connect the components, that is electronic components. So it uses conductive pathways, that is conductive tracks and drilled holes. Drilled holes are used to place the components on the PCB and solder them. And how to connect? The wires will not be used. Wires are not used in the PCB because the connections are printed. That's why it is called a printed circuit board. So why it is called a PCB? Since printing method is used, so to draw the tracks. So as I told you in the previous slide, that's why it is called printed circuit board or printed wiring board. Okay. See the earlier PCBs around in 1960s, how it was. See here, you can see the components how they have placed and wired, and this kind of PCBs were used in the earliest 1960s. So later on, to the improvement in technology, so next when vacuum tubes were used in 1980s, this kind of PCBs were used. These are all single-sided PCBs, and mostly connections are made using wires. The components are placed, soldered, and wires are used to connect the PCBs. See here, see the complexity of the boards. So later, what happened after 2000? So the technology improvements. The components, see the tracks, the connections are printed here. The drilled holes are plated, and surface mount technology. The components are, are the latest advancements after 2000. See the solder mask green. So this is solder mask is the outer coating. It is a non-conductive coating which protects the board to avoid the short circuit, and also to avoid the solder bridges in between these circuitry areas. So it will prevent the circuit from corrosion also, that is from oxidation also, because these tracks are made of copper. Okay, so copper pads and tracks, so this is called pads. So wherever the component is placed, so that copper area is called pad, and the connection is called traces or tracks. And see the silk screen, it is the whatever the marking is made, the component names and numbers, these are all called as silk screen. Okay. Next, drilled holes. So what is the use of drilled holes here? To mount the board, mount the components and solder the components. So it may be plated and non-plated holes. Okay, this is the top side and this is the bottom side. You can see the bottom side of the board. Next, see the electronic product flow. What is the electronic product flow? How it starts? Any electronic product. It starts from R&D, next CAD, CAM, and manufacturing assembly, and it comes to the end users as the end product. So first, to start with R&D, see the product design. It starts with the product design. Next comes the circuit design, then circuit analysis. The working of the circuit, the analysis is being done. Then later it comes to CAD. So after product design, circuit design, analysis has been done, when R&D part is ready, successfully completed, next that work comes to the CAD department. So here what happens, they will design there is the schematic diagram, already it has been designed here. The circuit has been designed in the product design part, that is circuit design and analysis part. So from this, the circuit, they used to capture it in a circuit, that is a schematic entry tool. So it is done by the layout engineer only. So he will draw the whatever the schematic is done here, circuit, they will write here. Then after that, layout has been designed. I will tell you the difference between schematic and the layout in the future coming slides. So next, the Gerber output files. So those are called as manufacturing output files are extracted from this CAD design. So this manufacturing output is given to the PCB manufacturing to manufacture the PCB. So before that, what happens here, CAM is there. So after this, there are different PCB manufacturers with different capabilities of manufacturing and different requirements of the board to manufacture. So based on that, see the CAM department what it does. So it will take the designed board and whatever is required in the manufacturing as in the fabricator manufacturer. So according to the manufacturing, the standard values are set up here. So design for manufacturing, DFM setup is done, and editing, whatever editing and panelization is done in this CAM department. So next, PCB manufacturing is done. Okay, after manufacturing, only PCB bare board will be manufactured here. After this, the component assembly is a separate part. So components are assembled into that bare board PCB. Then later it is tested for its working, and final it is sent to the end product. So this is the overall electronic product flow, starting from product design to end product. Now see the PCB types. The types of PCB: single-sided PCB, double-sided PCB, multi-layer PCB, HDI, high density interconnect, flex aluminum, and inertia. So what do you mean by single-sided? It means you might have seen some boards, printed circuit boards with single side components assembled on the single side top side and soldered on the bottom side. Connections are done on the bottom side. So in case of double-sided boards, components are placed on both the sides of the board, and connections are also made on both the sides are utilized for connections also. So these are called double-sided boards. Here the fabrication is slightly different compared to single-sided board. Again, multi-layer. Whenever the circuit is complex, and if you want to reduce the size of the board, so you can increase the number of layers, so that if the circuit is complex and you cannot make connections in the same one or two layers, you need some more layers to make connections. You can increase the layer count. So that is why multi-layer boards are required for complex circuits. High density interconnect. It means you might have seen the processors, computer processors with array of pins. So those processors are having pins of high density. So those are called as high density interconnect. So those kind of boards have small spacing, which has manufacturing difficulty. So that's why it is some again more complex. High density HDI boards are more complex. Next type is flex boards, flexible boards. You might have seen the flexible boards in some of the electronic equipments like mobile phones, flip mobile phones, and laptops and printers, hard disk, CD drives. You might have seen the flexible PCBs. You will see it later in next slides. Next, aluminum PCB. It is used for LED PCBs. And inner chip, this is the latest upcoming technology where it is called as, it is not exactly 3D, but we call it as 2.5D. So components are placed in the inner layers also. So that is inner chip. See, this is the example, a sample board for single sided PCB. Components are placed on the one side, and the other side is actually not shown here. It is tracks are drawn and soldered in the bottom side. See, double-sided PCBs. Actually, it is a bare board PCB. The components are not assembled, but it is a double-sided. The other side also has the circuit and components. Multi-layer PCB. There are number of layers. This is the top layer connections. The cross section is shown here, and the inner layers. See how many number of layers are there inside, and in between non-conductive pre-preg epoxy material is kept, and it is actually stacked up. High density interconnected PCBs. In this high density interconnected HDI PCBs, what is the advantage is it can reduce the number of the size of the board, and increase the number of layers. So the drill size also could be reduced, and also this is called blind vias and buried vias. So blind, it is the through hole, blind and buried vias. So blind vias means you can see the drill from one end and it stops in the other layer. Maybe from 2 to 3 layers it will pass. It will not pass throughout the layer. So this is called blind via. Buried via, which is buried inside, it is not shown here. That is called buried via, which connects only the inner layers. It will not reach the outer layer. It cannot be seen from after finishing the PCB. So this is the HDI. See, it is an example for HDI PCB where this kind of processors are used. See the connection complexity here. So these are all high density boards. That's why it is called high density interconnect. So this is aluminum PCB. See, there are a number of LEDs. What is the use of aluminum PCB? Because these LEDs, when it is used for a long time, that is powered on for a long time, it gets heated. So to remove the distribute the thermal conduction and remove the heat, aluminum material is used. Mostly the heat sink materials, aluminum only is used as a heat sink. But here, as LED heats up quickly, so to reduce the heat, aluminum material is used as a base material itself. So these are all the few other examples of aluminum PCBs for LED bulbs. See, you can see the 3D and flexible PCBs. See, this is a rigid, this is a flexible connection, and also rigid flex board. It is the combination of both rigid and flexible PCB. See, this is also a rigid and flex PCB. Few examples. See, it is a pure flexible and semi-flex. See, this is the pure flexible PCB, and it is a semi-flex. See here, this is semi-flex PCB. Okay, how to design this PCB? So we have discussed about what is a PCB and what are the types of PCBs. Now, how to design those things, starting from schematic capture to PCB layout and extracting manufacturing files. How to do schematic capture, how it looks like. See, after drawing the schematic circuit in a tool, schematic tool, it looks like this. A sample circuit is shown here. It is a PIC microcontroller 16F series, a simple board. So this is the processor IC. This is a connector. This is another connector called as jumper JP1, JP2, and IC, that is a regulator 7805 5-volt regulator IC, and which is connected V plus. This is 5 volt. It is connected here, and crystal oscillator, and these are all the simple connections of this. Now, see, in a schematic circuit side, it will be like this. What Whenever we design a circuit for theory purpose, we do it like this. Whenever it comes to reality, IC will not look like this. See, IC will be the real IC will be like this. It is a 18 pin IC, and see the jumpers and connectors here, and the other components are placed. So original component layout, this is the required output file, board file. So that is why this kind of schematic should be converted into this kind of layout. So this could be done using, there are lots of tools, PCB design tools. So few are licensed and few are free versions also could be downloaded from the internet. You can just Google, you will get many tools so that you can try to. So starting from schematic, you have to convert into the PCB layout and place the components are not already placed. We have to place the components wherever required, and we have to make the connections. See here, two layers, copper layers are shown, the brown color and blue color. So that it is a double sided PCB. So double sided processing has to be done here. Next, fabricating a PCB for simple circuit. So whatever the circuit we have seen in the previous part, so that circuit we are going to manually fabricate. See, these kind of circuits and some other complex circuits cannot be fabricated manually. So there are lots of automations are there, and lots of process are there. And also, to learn this PCB design, it is not possible in a single lecture to learn. It takes lots of hours to learn this. So in this the this is how that is the learning the whole PCB design is the out of the scope of this lecture actually. So we are briefly covering what is a PCB. You might have gotten a simple understanding about what is a PCB and how it looks, how design looks like. So next we will go for manually fabricating a PCB. So now you consider this LED power circuit. So we have previously seen one circuit. So that is a simple circuit. Before that, this is the original circuit where 230-volt AC is applied to this connector. It is a jumper connector. So this transformer steps down to 909 volt. So here 9 volt, 0 and 9 volt will be received in the secondary side. So this could be there is a full wave rectifier is used and capacitor filter is used, so that you will get a 9 volt DC in this line. So next, this 9 volt DC with the help of this switch, if this is connected to the number 3, then this AC circuit will power that is connect to the LEDs and power up the LED. Otherwise, this switch, if you connect the switch to the connection 1, then this will be disconnected and the circuit LED circuit will be connected from the battery. It will be powered from the battery. So this is a simple circuit to power up to LEDs. So we have designed for 9 volts, and we have shown the calculation in the previous part itself to select the resistor value. Right. Now we will reduce a few components when we go for fabrication. As of now, to learn what is fabrication, we will not make it complex. So we will reduce few parts where transformers are what to say, we find difficult to place on a PCB. As of now, we will not go for that. So we will start a connector here itself, and we will remove a few other components, the switches and other components which are not required as of now. See the simple circuit here, directly 9 volt AC, that is the transformer is separated, removed from here. Only 9 volt AC is applied to the diode, and the switch is also removed. As of now we are not going to use this. So battery is directly connected to this circuit. Okay, so we are going to fabricate these connections only. This is as you have seen the previous schematic part, we have to convert it into the layout, right? So how to convert into the layout? Manually we will convert. See how it looks like. So this is the top side figure is the circuit diagram. The same circuit diagram I have drawn here. This one I have drawn here. This is hand drawn circuit and hand drawn layout. See, this layout should be drawn on the bottom side of the board, so it should be in a mirrored fashion, mirror image of the circuit. See how it looks like. This 9 volt starts here, right? If you mirror this, what happens when you mirror this image? 9 volt comes to the right hand side, and next as the diode D1 and D2, so it comes next to this 9 volt AC. D1 and D2 comes in the reverse direction. Next to this, see there is a connection here, this connection, and next comes the battery. See the battery connection is left, plus and minus connections are left here. Next to that, resistor connections are given. Next to resistor, LED1 and LED2 connections are given. So this should be the way you are going to draw a layout if you wanted to draw manually. But if you are using a tool, it automatically it takes it like that. So when you design it automatically, it will design the layout in the mirrored fashion only. So when you take it as a bottom layer, so that doesn't matter now. Now when you draw it manually, you have to follow this method. Okay, now this is the layout. We are going to draw this layout in a copper clad laminate. What is that copper clad laminate? Let's see in the next one. See, this is the etching part. So after drawing this layout on the board with the help of the marker pen, see, draw in this fashion. So starting from the AC, there are diode options here, then battery option here, and then the resistor and diodes, LEDs. It is in a mirrored fashion as drawn as it is. And the other copper areas, it is a plain copper board. So except these areas, the copper should be removed from other areas. This copper should be removed. So what we have to do, we have to place this board in a ferrous chloride solution. Okay, so what happens, you have to give proper agitation, so that after 15 to 20 minutes, what happens gradually we will see in the next coming slides. See how it is removing the copper. This area coppers are removed. Again gradually you see the next. It takes some time. So next, after some time, what happens? See, it is almost fully removed. After this, what you have to do, you have to remove the board from that. Take the board out and clean this using the thinner. You have a thinner solution. Clean this marker ink using a thinner and wash with water. After washing with water, dry the board or wipe with a dry cloth. Okay, so next what happens, it looks like this. See, all the other parts are etched out, only copper area looks like this. Only wherever connection is required, copper area remaining is there. The other areas copper is removed. Okay, now what you have to do, next process is drilling. Wherever you need to place the components, you have to drill. So you have a manual drill, you can use a manual drill here because it is a simple circuit, you can do it. So after drilling, it is not completely completed now, but a few 3 drills are done. Now it is shown. See, as per the layout, it is shown here. So the drilling is done. We will go to the next part. See, after all the component places are drilled out, and this is the top side. So actually this is the bottom side, And if you see from the top side, you can draw this circuit as it is for ease of connections. So when you assemble the components, which component how to connect. So if you draw the circuit like this, it will be easy for you to assemble. See, after assembling, how it looks like. See this 9 volt AC is should be given here in the from the bottom side. The soldering should be done from the other side. This is the top side of the board. So as I told you, the silk screen is the marking of the components. So you can say this is a silk screen. There is a D1, D2, 9 volt AC. These are all markings should be done on the top side. Okay. So these connections are like this. And next, after assembling the components, now you see the bottom side. Say how it has been soldered. This is the top side. Bottom side should be soldered, right? So how it has been soldered. See, the component pins are connected soldered, and above the copper, see, full and full solder lead material is applied. Why it is applied like this? Because if you leave the bare copper, see here, the bare copper as it is, easily and quickly it will get oxidized and corrosion occurs. To prevent this copper material from corrosion, either you should use a solder mask. So solder masking is an automatic process and it is a huge costly process. You cannot do it here manually. So we are what we are doing is we are applying the solder lead here. So it will protect the copper from oxidizing. So that is why it is applied like this. And the wire is also connected here. The battery is connected. So next, see the final working of the circuit. It's simple. A battery is connected. The LED is glowing. So how to select a resistor value, that calculation we have seen in the previous part. So this is the this you can use this video to learn how to do a small calculation and how to fabricate a simple circuit. Hope this will be useful for you, and this will be a very good motivator for you to learn these concepts in depth in future. All the best. Thank you.